You'd like to find Taylor series for the function e to the x minus 1 about the x value of 1. Okay, we know that any derivative, first, second, third, etc., is equal to the same as the function, right? Because the derivative of x minus 1 is 1. 1 times the original gives you the original, right? So it's unchanged. So that's good. That makes it easier. We know that the Taylor series is coming of the form the kth derivative at x is equal to c, which is 1, right? The kth derivative at x is equal to 1, divided by the k factorial times x minus c, which is 1, to the k. Right, so that's going to be what? Let's find first 3 or 4 terms. The function value, when k is equal to 0, we're talking about the clean function, not the first derivative yet, right? So just the clean function x is equal to 1, right, which is the c value. So I'm going to circle this so that we're always seeing it. 1 minus 1 is 0, right? So the function value at 1 is e to the 0 divided by k0, right? So 0 factorial times x minus 1 to the k is equal to 0, so 0, plus, and notice that e to the 0 will always be there because because the derivatives are all the same functions, just like the given function e to the x. So we always going to write e to the 0 first, and then 1 factorial because k keeps increasing. And x minus 1, the power is the same as the factorial, right? Because k factorial, k power is the same, right? 1, right? Plus e to the 0 again, that's unchanged, 2 factorial times x minus 1 squared, etc., right? We already see the pattern, so we can express this as a Taylor series. We'll find the Taylor series now. So e to the 0 is always 1, right? So we can disregard that. Let's take care of the factorial. We know that the factorial is going to be the numbers keep increasing by 1, right? And they start from 0. So k starts from 0, so it's just k factorial. That's fine. Now there's 1 in there, right? So we can just write 1. And then here we're going to write x. So x minus 1 to which power? Right? The powers match the factorial numbers 0, 0, 1, 1, 2, 2, right? So we can just write, since there's a k, we can just write k in there. That's it. We found it. Okay, so now in order to find the interval of convergence, right, in order to find the x value range, that is, for which the Taylor series converges exactly into the function e to the x minus 1, we need to use the ratio test for absolute convergence. Right, that's why we're using the absolute value, the ratio test between two successive terms. I'm going to find the limit value of the absolute value of that ratio, right? And the ratio will be between two successive terms of the given sequence, not the series, not including summation, but we're talking about the sequence here, right? So that's going to be, let's see, that's going to be x minus 1 to the k plus 1 over k plus 1 factorial, right? Because that's the current term, divided by the previous term. And the previous term will be without k plus 1 is going to be k, right? Which you see here. But we can't, instead of dividing by this whole thing, let's multiply and flip this fraction. Right? So k will be, k factorial goes on top, x minus 1 to the k goes on the bottom, like that. Okay? Then what do we get? Notice that this can be expressed as k plus 1 times k factorial, right? So the k factorials will be gone, right? Because we factored out the k plus 1. And also this guy is gone and this guy is gone. Well, I should just cross out the k and then 1 remains, right? X minus 1 there remains. right? So what are we going to have? We're going to have basically the limit as k approaches infinity, absolute value of x minus 1 over k plus 1, the lone k plus 1 that remains, right? So it has two possibilities. It has a possibility that the limit value is 0 if x is set to 1. Right? If x is set to 1, this whole thing is 0. The limit value is 0. However, if x is not equal to 1, then we would take the limit, right? Because it would be non-zero on the top, and then the limit value as k approaches infinity would be infinity on the bottom, and any non-zero divided by the infinity is 0, right? So if x is not equal to 1, this limit is still 0. So what does that tell you? It tells you that there is absolute convergence at all x values, right? All x values. And what does that mean? It means that the interval of convergence is from negative infinity to positive infinity, right? Because we know that for any x value that you choose, you will always have the convergence value of 0, right? Okay, so thanks for watching. I hope this was helpful, and I'll see you in the next videos.